This video will go through a few examples of solving rational equations. I've taken the 3 different problems from CUDA worksheets. There are different ways you can go about solving these types of equations, and I'm going to try and show you a few different strategies over these next 3 examples. With this problem, I'm going to get a common denominator between these two terms so that I have one fraction equal to one other fraction once I combine these two terms, and then I will be able to cross multiply. It's pretty easy to get a common denominator here because this is just a 1, and so I just have to look at whatever this denominator is, in this case n plus 1, and I'm going to convert this 1 into n plus 1 over n plus 1. So I've rewritten it here. You can see this is equivalent to 1. Now that I have my common denominator, I'm going to add these two numerators, and this will become one fraction. As I said, now that I have one fraction over here, and it's set equal to another fraction, I'm allowed to cross multiply, which means I'm going to do one denominator times the opposite numerator and set that equal to the other denominator times the other numerator. I'm going to leave everything factored to show the next step. Now that I've cross multiplied, I'm going to expand each side by multiplying these terms out. Some of you might know this as foiling. I also wanted to explain that the order in which I wrote these factors does not matter because it's multiplication. So I will now expand these terms. Now that I've expanded each side, I have two quadratic trinomials, and the next step is going to be to combine any like terms. Hopefully you've noticed that in fact I can cancel these n squared terms because if I were to try and get them on the same side of the equation, they would cancel each other out. I'm now going to move this 6n term over here so that I keep it positive, and I'll move the 56 over here, which will create a negative number, but that's okay. If you want to do it in the opposite way, that's fine. We're both going to end up at the same answer. When I divide both sides by 9, I get negative 51 ninths, which is divisible by 3, so my final answer for n is negative 17 thirds. One more thing that I wanted to mention was that if we look back at the original equation, I need to note that if I get an answer of n equals negative 8, that actually is not going to work in this problem because this equation is undefined when n is negative 8, because that would make this denominator 0. Similarly, this is undefined when n is negative 1. Let's look at another example. In this example, I have the same denominator in two of the fractions. They're on different sides of the equal sign, but I could move, for example, this fraction over here and combine the numerators. However, I could also do what I did in the last problem, which is to make this 1 3x over 3x. That's what I'm going to do because I want to show you that if you have all of the denominators the same in your equation, you can actually eliminate them. Okay, I've rewritten 1 into a more helpful form so that I now have the same denominator across this equation. And as I was saying, I can actually now get rid of this 3x that's in the denominator, and I no longer have a rational equation that I'm working with. To show you why that works, I will combine these two fractions and then explain. Here's my combined fraction. And to explain why I can just cancel these, it might make sense if I show you that I could multiply both sides by 3x to get rid of this 3x here. But when I do that, I similarly get rid of the 3x on this side. So in fact, I just have the numerators of each of my fractions. So whenever you have fractions that all have the same denominator and you're dealing with an equation, you see an equal sign here, not an expression, you are able to cancel those denominators and just focus on solving the numerators of the equation. So I will do that now. Okay, so I have my two numerators. This is a quadratic equation, so I'm going to get everything on one side of the equation and set it equal to 0, and then I'll factor. So here I've set my quadratic equation equal to 0. Here I found my two factors, and when I set each of those equal to 0, I would get that x equals 6 and x equals negative 3. I want to just check my original equation to make sure neither of those values makes my denominators 0, and they don't. The only value that would make the denominators 0 here is if x is 0. So actually I should have said this earlier. You might want to write a little note to yourself with what are your excluded values. So when x is 0, that means that this equation is undefined because it makes the denominator 0. So if this becomes an answer, I know that in fact it's not one of the answers. In this case, that was not an issue. Let's look at one final example. Okay, in this example, it looks like it might be complicated to get a common denominator here. I already have a common denominator here, but in order to combine these two fractions, I need a common denominator. And in fact, if I were to factor this denominator here, I could factor out a p from it, and I'm left with p plus 1. So even though these look different, in fact, this fraction is just missing the factor p. So to fix that, I'm going to multiply this last fraction by 1, of course, in this case p over p, because that's a more usable form of 1 right now. And then I will have the same denominator in all three of my fractions as I did in the last example. Okay, so after multiplying this final fraction by p over p, this is my result. I wanted to mention too, though, that because each of these denominators had a factor of p plus 1, remember this is really p times the factor p plus 1, because they all had a factor of p plus 1, I could have actually eliminated that from each of these denominators. However, I'm going to now eliminate the entire denominators, so in fact it didn't really save me that much work. So as I mentioned in the last example, because all of my denominators are the same and it's an equation, I'm allowed to cancel these denominators, and I'm just going to solve the equation that I see in the numerators. So here is the equation that I saw in the numerator. I put some parentheses around this second fraction because a lot of students forget that when I'm subtracting more than one term, I have to remember to distribute that negative. So in fact, it was minus p squared minus negative 6p, which becomes plus 6p. I have here another quadratic equation. So like I did in the other example, I'm going to move all of the terms to one side and set this equal to 0. Now that I have my quadratic equation, I want to factor it. This factors nicely, and then I'll set those factors equal to 0 and solve. So I have two answers again, p equals 4 and p equals 1. Now I forgot to take my own advice and at the start write down the values of p that would make this equation have an undefined value. So again, I can't have 0 in the denominator. And so if I use this factored form here, when p is 0, I get an undefined value, so I cannot have p equal to 0. And when p is negative 1, I would also get 0 in the denominator, so I don't want p to be negative 1 either. But looking at my answers, neither of those is a problem, and so I do have two answers, 4 and 1. I hope this video was helpful, and I promise that with more practice, these will start to get easier.